The degree of a polynomial function affects the shape of its graph and determines the maximum number of turning points, or places where the graph changes direction. It also affects the end behavior, or the directions of the graph to the far left and to the far right. Take note, key concept, polynomial functions. You can use the graph of a polynomial function to determine turning points and end behavior. The following functions demonstrate the four types of end behavior. You can also identify the intervals over which the functions are increasing and decreasing. A function is increasing when the y values increase as the x values increase. A function is decreasing when the y values decrease as x values increase. First note the equation y equals 4x to the fourth plus 6x cubed minus x. We can state its end behavior is up and up. Note the first up refers to the end behavior on the left of the graph, as it's exiting our viewing window in an upward direction. The second up refers to the end behavior on the right side of our graph. Again, it's exiting our viewing window in an upward direction. And note the turning points on this graph. First, negative 1.07, negative 1.04. At this point, the function changes from being a decreasing function, or an interval where the function is decreasing, to an interval where the function is increasing. And it's at that point, negative 1.07, negative 1.04, where the function is making that change from decreasing to increasing. Next, the point negative 0.27, 0.17. Here the graph is changing from being increasing to decreasing. Finally, the point 0.22 and negative 0.15. At this point, the graph is changing from decreasing to increasing. The function is decreasing when x is less than negative 1.07, so to the left of our farthest left turning point, and on the interval from negative 0.27 to 0.22. So we can state that with this compound inequality. Negative 0.27 is less than x, which is less than 0.22. Note that the function is increasing when negative 1.07 is less than x, is less than negative 0.27, and on the interval where x is greater than 0.22. Note this function, y equals negative x squared plus 2x. Its end behavior, down and down. It has just one turning point, the vertex of the parabola, the point 1, 1. Notice at the turning point, the function is changing from increasing to decreasing. The function is increasing when x is less than 1, and the function is decreasing when x is greater than 1. And here's the graph of y equals x cubed. Its end behavior, down and up. It has no turning points, and the function is increasing for all values of x. Another cubic polynomial function, y equals negative x cubed plus 2x. Its end behavior, up and down. Its turning points, negative 0.82, negative 1.09, and 0.82, 1.09. The function is decreasing when x is less than negative 0.82 and when x is greater than 0.82. The function is increasing when negative 0.82 is less than x, which is less than 0.82. You can determine the end behavior of a polynomial function of degree n from the leading term a times x to the nth power of the standard form. Note this table. End behavior of a polynomial function with leading term ax to the nth power. If a is positive and n is even with n not equal to 0, the end behavior is up and up. If a is positive and n is odd, down and up. If a is negative and n is even with n not equal to 0, down and down. And if a is negative and n is odd, up and down. In general, the graph of a polynomial function of degree n with n greater than or equal to 1 has at most n minus 1 turning points. The graph of a polynomial function of odd degree has an even number of turning points. the graph of a polynomial function of even degree has an odd number of turning points. Problem 2. Describing end behavior of polynomial functions. Consider the leading term of each polynomial function. What is the end behavior of the graph? Check your answer with the graphing calculator. Part A. Y equals 4x cubed minus 3x. The leading term is 4x cubed. Since n is odd and a is positive, the end behavior is down and up. Don't forget to confirm with the graphing calculator. Part B. Y equals negative 2x to the fourth power plus 8x cubed minus 8x squared plus 2. The leading term is negative 2x to the fourth power. Since n is even and a is negative, the end behavior is down and down. Don't forget to check on a graphing calculator. Your turn. Consider the leading term of the polynomial y equals negative 4x cubed plus 2x squared plus 7. What is the end behavior of the graph?